All right, here we go. This is lesson 3.4 homework. It's 8 questions, but of course, some of those questions have multiple parts. Ricky, are you on it right now? Good. You have pencil and paper out right now. Let's get started. Number 1 says, tell whether the point 4, 4 is on the graph of f of x equals the absolute value of f of x. If it is, give the coordinates of another point with the same y value. So that's kind of like a 2-part question. The first thing we're going to figure out is this coordinate pair 4, 4 on this graph? What do you guys think? Is it hard? Is it kind of hard to tell without graphing it? Okay, so let's go ahead and draw some values or make some values for our input, put them into the machine, the function, see what comes out, we'll graph it, and then we will determine whether 4, 4 is on that. Since we are, let me just do it like this, okay. Let's say we always want to have some negative values when we have an absolute value function. So let's say we're going to have an input and we'll use -1, 0, +1. I'm going to go ahead and also include a +4 as an input since we're specifically looking for this coordinate pair. I want to see, is this going to give me an output of 4? Let's see. Now, we could put this as the y values, but since we're working with functions, the y is actually called the function of x. It's the same thing as the y value. It's all the output. Hi.
Sorry, there was an accident like right there.
Oh, no problem, no problem. We're just we're working on homework right now. I'm recording so that everyone else from algebra has homework help along. So if you could just like be kind of in the background, making sure that specific people are working and taking notes, that'd be awesome. Thank you. All right, so we have our input values, and we definitely want to see if 4 is on there. Now, technically I don't really need to do all this, I don't need to graph it, but I'm going to anyway because graphing absolute value fractions and functions is so much fun. Okay, so the function is the absolute value of x. So what's the absolute value?
What's happened?
What there? Oh! Somebody just. Oh,
I feel like
it was
it's
Mr. Williams.
Yeah.
Definitely Mr. Williams. He just booted me out. That's okay. And then he realized that if he was the wrong.
I think
so.
I don't think he knows what room he's in.
That's okay. He probably just clicked the same. He has to move rooms like all day, so it's really hard to remember which room you're in. Okay, what's the absolute value of -1?
1.
Good. Let's try 0. What's the absolute value of 0?
0.
0. Absolute value of 1.
1.
Absolute value of 4.
4.
Okay. So just looking at this input-output table, can we see that is the point 4, 4 on the graph? Yes.
Oh, yeah.
4, 4. That is going to be on the graph. If I were to go ahead and graph it, I would have -1, 1, 0, 0, +1, 1, and then I'd have 4, +4, 4, 1, 2, 3, 4, 1, 2, 3, 4, and I'd have it like right here, and you can see that I have an absolute value function. I would probably also get a -4, 4 if I wanted to, right? Because a -4 absolute value of -4 would also be +4, so you can see we have our perfect little V. But here's what we're looking at right now. We have +4, 4, so that is a yes. Because it's a yes, it says if it is, give the coordinates of another point with the same y value. Whoops, I already did it. I already did it just to make sure my V is nice and V-shaped. What did I do? how did I already answer this?
Wait, hold on, what's the question?
The question is, if it is, which we have proven that 0.44 is a part of this function. 4. It's part of that beautiful absolute value v, right? Are you on this question? Okay, good. And Zach's just working on geometry, so he's good. Zach, if you have any
There's
questions.
no homework. He didn't submit the homework yet. Like,
So there is
it's
homework,
like-
but it's not posted?
Yeah, it's not posted, so I can't do it. It's
Can
like,
you go-
it's like every day. Like he doesn't post it.
Do me a
so-
favor, go to the front office. Actually, go to the classroom. Do you know where Mr. Witten's classroom is?
Isn't that upstairs in Miss Kerr's room?
It's literally at the top of the stairs.
Yeah.
Go to the top of the
turn
stairs, and it's
right.
it's the very first classroom at the top of the stairs. It's like the end.
It's the first when you walk.
I think it's 203.
It's the Grand
It's
Adventure.
very good. So if Mr. Williams isn't in there, Mr. Witten probably is. Somebody will be in there. Ask them to put it on so you can work on your homework. Okay? And then when he comes back, if he needs help on geometry, you can help him. All right. So we found that we have.
If I come back and I don't know where the room is.
Go. You know where the stairs are, right?
Yes.
Go to the top of the stairs.
Okay.
As soon as you walk out of the door from the stairs, look across that 3 feet of the
I
hallway.
think I know.
That's the very first classroom.
Read the signs.
Yeah, 203, I think. And it says their names on it. It says their names. Okay. All right, we found out that 4 is on it, so that is a yes. Then it says if it is, which it is, give the coordinates of another point with the same y value. What's the y value here? 4. So a y value of 4, what would a different point be? Very good. -4. 4. Which I kind of accidentally already did because
Do you have to put the parentheses?
yes. Look, they're asking for a different point on this graph that will also have the y value of 4. Yeah.
Not for me, I got it right.
Did you put parentheses?
Yeah, put parentheses.
Did you do 4, -4? I mean, I'm sorry, did you do -4, 4?
Do you have the same number?
Emily, do you have the same numbers?
Nope.
Is that why? Okay.
Oh wait.
If you have different numbers, you have to go according to your numbers. Notice that the
Right.
difference will be, you just have to negate your x value. And that is the correct answer.
negative.
What?
We just make the x value negative.
Mhm.
Oh, okay.
Because it's absolute value, both +4 and -4 will give you an output of +4. That's what they're trying to get you to practice here. Yes. Correct. Did you get a negative for your first value? Very good.
I also did the second question and the third question.
Well, that's just wonderful. You might want to just go.
The fourth question, the third question was
Okay. All right, so we have a question that's just like it, right? So, does this work? Is this going to work for this very same function? Let's think about this for a second. We're having positive input going into an absolute value function. Is it going to come out positive or negative? Were you able to contact them?
He
Yeah,
said,
I said okay. Yeah.
He said what?
I asked him and then he said okay and then I just
Mr. Williams?
yeah.
Oh, so
Yeah.
is he in the middle of teaching?
Yeah.
Okay, was Mr. Whitman there too?
No. Well, he said he's doing it.
He said he's gonna do it right
Yeah.
now? Okay, great, check, just refresh and check to make sure it's in.
Also, which is kind of funny, my sister's in that class.
Oh.
And then she's like, Zachary, I think you're gonna have to.
Okay, so this is a very similar question. They're asking the same thing. They're giving you a coordinate pair. They're asking if this coordinate pair, this point, will be on this function, which is just like and it's exactly the same function that we just did. So if we take our input value, 8.8, and we plug it in to here, what output are we going to get? What?
Positive.
It's going to be positive.
Are we on question 2?
This is question 2.
Oh.
So if we plug in a positive or negative input, the output is going to be positive. So this output is negative. Is that going to work?
No.
No, because if it's being absolute valued, which is probably not a real verb, but I made it a verb. If it's being absolute valued, then it can't turn out negative. Unless your function also says like -1 times that. But that's not what this function is. So the answer is no. Which is easy because then we don't have to find the other point.
Oh wait, would mine be mine?
What does yours say?
Mine is -8 and 3.
Yours says -8, 3.
It's still the same answer.
Yeah.
Oh, well.
Is it the same function? Is it f of x equals the absolute value of x?
Yeah.
Okay, and your coordinate pair that it's giving you is -8, 3? Okay, well you tell me. Plug in -8 into the absolute value function. What comes out?
8.
Good. Is that what that is?
Mm-hmm. Yeah.
This says a 3.
Yeah, it's positive.
Okay, oh no, okay. You said -8, 3. So that's what I wrote. You meant to say -8.3,
Oh,
positive 8.3. Is that what you meant?
yeah.
Okay,
Except the 8 is also negative on the other one.
so this is also negative?
That's how mine works.
Okay. So let's try this again. If our input, -8.3, gets absolute valued, what comes out?
Positive?
Positive. So is this a possible point?
No.
Did that answer your question?
Yeah.
Okay.
So it's still be B?
Correct. Remember that you have to take all notes during this. It is recording, right? I just want to make sure. I always get nervous that I forget to record. All right, so it says describe the key features. This is a multi-step question, I believe. Yep. Describe the key features of the absolute value function. Identify the vertex, the axis of symmetry, and the domain, and the range. So that's like 4 questions in one. So we have our x and y table, or our x and the function of x table, which we all know is the same thing as our y, or the same thing as the output, as this is our input, right? Okay, so there are a couple of different ways to do this. I would just go ahead and graph those points. These are coordinate pairs, x, y, x, y. Go ahead and graph them and see what they look like. Can you see this on my recording? Now, can you pull it back just enough so you can see this whole? That should be good. You can see that whole thing now? Okay. Thank you. All right. Ricky, make sure you're getting all this down, okay? Callie, you have to have notes out. Okay, so I'm going to go ahead and graph it. My first coordinate pair is -2, -6. -2, 1, 2, 3, 4, 5, 6. Then I have -1, -3, -1, -3. Then I have 0, 0. Then I have 1, -3. Oh, it looks like a Christmas tree. And then I have 2, -6. And then I connect my dots, and I have my Christmas tree. I should have used a green marker. Okay, so I have my absolute value function, and it says describe the key features. First, we're going to identify the vertex. What is the vertex of that absolute value function?
0.
What is it?
0.
Keep going.
And
0, 0, right? So the vertex is
Parentheses,
0, 0, parentheses, 0, comma, 0.
It's like,
Yes.
What's gonna be the note for this
What's going to be the what?
question? The note. Like,
The note. Oh,
yeah, like,
you don't have to because I drew this function for you. It's more like make sure you're getting something. Yeah. So you got your notebook out. That's great. It has to be open. Okay.
it doesn't stay open, that's why I don't have it open.
Just put your laptop on top of that first part. There you go. All right. So now it's asking for the axis of symmetry. Let's look at our graph. What is the axis of symmetry? So that's the vertex, and you're on the right track because the axis of symmetry is going to be the line that goes through the vertex, right?
or X equals 0.
Genius over there. Here's a lolly for you. Good catch. Okay, he didn't just say the y-axis, which is true. The y-axis is our axis of symmetry. But he saw that the question asks for an equation. So we can't just say the axis of symmetry is the y-axis, even though it's true. We have to say the equation for the y-axis, which is really strange. The y-axis, the equation, why doesn't that look like a y? There we go. The y-axis, the equation is x equals 0, because every point on the y-axis has an x value of 0. 0, 0, 0, 1, 0, 2, 0, 3, 0, negative 1, 0, negative 2, 0, negative 3. Every x value is 0, so the equation for the y-axis is x is 0. Okay? That's it.
We just write x is 0 or equal.
X equals 0. Yep. Sorry, is means equal, but it's is. All right. Now it says, more questions in the question. What is the domain of the function? So let's take a look at our graph here. What is it?
X is a real number.
Yeah, x is a real number. Even though it kind of looks like, wait, but isn't it like all the way down here? It's not up here. Yeah, that has to do with the range. But the x values start at 0, right? And it goes out, 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 out. Yes, it's going down, but it's also going to the right. As it goes down, it's also going to the right, and to the right, and to the right, and to the right, to positive infinity on the x. And then from 0, it's also going to negative infinity on the x, which includes all real numbers. So we would say that x is a real number, which is, what's that? What do you think? Let's look at that. Are you saying that for this exact function, that the range, the y values could be anything, both positive and negative? On this function, could a y value be up here? No. The y values start at the origin and go down. So how would we describe that? Hold on, Ricky, I want to see, you're doing great, but I want to see if anybody else can help me. Angelique, can you help me? How can we describe what our y values could be? If the y values start at 0 and continue all the way down, how would we write that? You don't know? What you would, you're right, you could say y is all negative real numbers. The only tricky part is that there's one tiny little number that has to be included in it. But if you just say negative numbers, it doesn't get included. What's that tiny little number that has to be included?
1.
1? Why is 1 is up here?
I know, negative. No.
No, if we say it's all negative real numbers, then what's that? 0. Very good. So how can we write that in a very concise little inequality? There's your hint, Angelique. How can we write that if we're going to use an inequality and say y has to be what?
Greater than, like, what do you mean? Less than? or
Yes.
equal to?
Very good. Less than or equal to 0. Very good. All right, so we're going to type that in so I can get the next question. What? Yeah. So the range is, no, it's not discrete because it continues. Discrete would be if it had specific points that were not connected. So the range is not a real number. Okay, that's not that, that's for something else. The range is single continuous interval that contains more than one values and it's not all real numbers. The range is, it's choice D. Y is,
No.
it's not, what?
What, for me,
Less than.
Abby,
Oh, I'm sorry, for me it's choice D.
for me.
It's the range is a single continuous interval, which means it's going all the way, that contains more than one value, and it's not all real numbers, it's simply y is less than or equal to 0.
Miss,
Yes? Gosh, there's another part to this question.
Alright, it says it's wrong, I was the same thing as
Miss,
you
like,
want me to put in, like,
Let me see. Did you put y is, did you put y is,
put in 0? I just-
no, you have to say y is less than, because that's in set builder notation. Set builder, this is, what I wrote up here is what you're supposed to type in. What they started is set builder notation. Yes. So set builder notation identifies your variable, then has a slash, and then you write your inequality.
But, Miss, like,
Yeah.
I don't have the less than thing. I don't
She doesn't have it on her.
I don't have it.
I can show you how to do it on your computer.
Miss,
Okay.
like,
So, oh my goodness. Does anybody else have this issue?
no, you just have to finish the question and then.
Let's see, settings, on-screen reading or accessibility, what's that?
Oh, you have to have it on,
Yeah, I know, but is this accessibility? No. So if you. Okay, there is an, oh no, I can't do, I don't know how to do lesson or.
You still didn't put up the homework yet.
You didn't?
Yeah.
You can go up and ask them. Or you can, would you do me a favor, go to the front office, ask which classroom Mr. Witten is in, and see if Mr. Witten can do it. Can you just explain that Zach asked Mr. Witten to do it, and so they do it?
thank you.
It's the geometry homework.
Yes, geometry. What is it, 5.1?
5.1.
5.1. Oh, Mr. Oh, yes, yeah. Thank you. Mr. Witten? Mr. Witten, could I borrow you for 1 sec real quick? Thank you.
Do I just like type it in words is less than or equal to?
It's gonna count it wrong, but since we're doing this together, just email me and I'll just give you 100 on this, okay? Because we're doing it together. It's okay, don't worry about what that says. I control the grades. Canvas does not. A real quick question,
He had an issue with it,
Oh.
so I fixed it for those because like he said he had it for this class, but I'll have it. I'll have it. Should work on a skill.
Okay,
So just what skill are you working on?
we're
right now?
doing algebra right now.
Okay, so
Okay.
you could benefit from it.
What do you want?
Okay, so
So
you're going to.
it'll get posted, just,
Okay.
Okay.
I was just like,
I know, you're wanting to work on it, I don't blame you. I'll get it posted shortly.
thank you.
Yep. That's it.
Yeah, that's it. He went up to ask him and he said he would do it.
Well, he's teaching you.
No, I know, that's why I told him that and he was like, oh, I'm just gonna do it right now. And I was like, oh, okay, with me.
We're gonna go over that.
All right, so Zach, you get to pay them for this lovely situation.
Yeah. I'm just doing the Spanish stuff right now so I can actually do something. No, we're doing the study guide instead of we have to do the entire study guide instead of. Is it a Greek?
What?
It's on the Greek.
I can't hear you, what? Have we done this? Yeah, I'll walk you through it. Don't go ahead. All right, I want to get this whole thing done, so let's keep working.
Is this another part on it?
Yep, another
I
part.
have another part on it.
Are you sure?
Yeah.
You should say describe the intervals over which the function, oh wait,
Yeah, it's higher than they are as an entire
Yeah, I don't have it. That was the most.
Yeah, you're on the back of there. You're on part 505.
oh, I'm sorry. That's because I started doing this earlier and it saved my answers. So we're actually on part, I'm gonna start with part 1. It's gonna have the answers filled in, but we're gonna go over it together. So this is question 4. I think I just switched to question 4, right? Okay, yeah, we finished up with question 3. This is question 4. It says graph the following function. What are the domain and range? So this is question 4. Okay, does your function say 3.5 times the value of? It does? Everybody does? Okay, great. So we're working with the same thing. So the first thing that I did, and I already graphed mine, just long story, I just had to do that question to email the company about something. So, the way that you would graph it is, again, make your input-output table. Your input being x, and your output being the function of x. So this is called h of x, so that is our function of x. So we're going to input some values. Now, the great thing is, graphing digitally only requires your vertex and one other point. So I just keep it really simple and I just graph -1, 0, and 1. Or I just input those and then I find the absolute value of my input, which is -1, which would be +1, and then it says to multiply that times 3.5, which will give us, so +1
Oh.
times 3.5 would be 3.5. Good. Now the absolute value of 0 is times 3.5 is 0. And the absolute value of 1 is
1.
1 times 3.5 is 3.5. Notice that's how we're getting our v. A -1 is going to give us a 3.5, and a +1 is going to give us a 3.5. So when you graph this, first start with your vertex. You have to click on the little picture that has the v. Then you take your vertex 0, 0. You plot that, and then you can plot either one of these points. You only have to plot one of them and it'll automatically make your function, your v. And then like, for example, if you plotted like -1 and then 3.5, be really careful with those halfway. So plot your vertex first, which is 0, 0. Then plot, you can either do -1, 3.5 or 1, 3.5. So -1, 3.5 would be about here. It does allow you to graph halfway. You might want to zoom in on your graph to make sure that you can see those halfway points. Yeah, that looks great. Check your answer and make sure it's right. It says it's wrong.
Not
Mhm. All right, I don't want to run out of time, so I'm going to keep going. All right. What is the domain of this function? So let's go ahead and look. Whoops, I scrolled. What is the domain of this function? Anybody? What is the domain of this function? What is the, tell me what a domain is. What values? X. What are the x values of this function? 1 is definitely on there. Yep. -1 is absolutely on there. 0. What other numbers could be on this?
No. I was gonna say 3.5 because.
Okay, so if we look at our x values, you said 1 is on there. Yep, 1, because that will be a point up there. What about 2?
Yeah.
What about 1.5?
Yeah.
What about 1.1? What about 6? Really? So if this line increases and increases and increases all the way up there,
Yeah.
will 6 hit it?
Yeah.
What if the line goes on forever, which it does? Even though it looks like it's going up, it's not going straight up, it's going diagonally up. So as it continues for 1,000,000 years, is it going to hit all of the x values on the positive side? Is it going to hit all of the x values on the negative side?
Yes.
And it hits 0. So what do we call that? All real numbers. Or we would say x is a real number. And then the range of this very same function over here. Is it good? The range on this very same function, we're looking for our y values. What y values are allowed on this function? Let's look at our y-axis. Let's look at the positive parts of our y-axis. Are they allowed? Yeah, because all of these things are covering the y-axis. As it continues, is it going to keep going up the y-axis?
Nope. Yeah.
Yeah. Now, is 0 also allowed? Good. Is -1 allowed?
No.
Is -2 allowed? So Emily, you said -1 is allowed.
No, I wasn't paying
Oh, okay.
attention.
You're just like, I was gonna tell you what you want to hear. -1 is not allowed. -2 is not allowed. -0.5 is not allowed. -0.12345 is not allowed. Nothing is allowed down here. So how would we write that in a very concise way? It's very similar to what we wrote for the other one.
It is greater than or equal to
Yes. Y is greater than or equal to 0. So it would be a single continuous interval that contains more than one value, but it's not all real numbers. It would be y is greater than or equal to 0. Now here's where things get funky. And I got cold again.
This way.
Yeah, sure. Describe the intervals over which the function is positive. Let's decode that for a second. Describe the intervals over which the function is positive. What it means by the intervals, it means the x value intervals, because it says describe it over which the function is positive. The function, which is this, is that our x values or our y values? Our y values. So describe the x values over which the y values is positive. So, how can you just explain that? Don't worry about what that says. How can you explain that? Over what x values, meaning what x values are allowed to make the y values positive? Is the x value 2? Will that make the y positive? Yes. What about 4? What about 10? What about 1,000,000? What about 0.2? What about negative 0.2? What about negative all the way down here? Good. So it kind of sounds like it's all of the x values, right? So the only x value that doesn't allow the y value to be positive is what? 0. Very good. Because the x value, 0, makes the y value 0, which is neither positive nor negative, so we can't say that that's included. So the way that they write it, it's a little bit different than the way that it's written in the examples that we're going to go over today. But we would say the function is positive over 2 separate continuous intervals. Basically, everything that's not this. It would be this and this, 2 separate intervals. The leftmost interval is x is less than 0. The rightmost interval is x is greater than 0. So it's basically saying, now your textbook in the examples, if Abby and Ricky remember from this morning, and Callie, your textbook in the examples describe it as basically values where x doesn't equal 0. This is just a different way of writing it. It's 2 separate intervals. One is this and one is that. X is less than 0 and x is greater than 0. Yeah, we only have a few minutes left, so let's kind of breeze through this, okay? Describe the intervals over which the function is negative. Describe the intervals over which the function is negative. Oh no, I have to scroll back up. All right. Describe the intervals over which the function, meaning the y values, are negative. Tell me what x values allow the y values to be negative. 0 makes it 0, which is neither positive nor negative. Tell me what x values will allow the y values to be negative. Callie, what do you think? Can you name a negative y value on this function? No. So what x values allow it? What x values allow it to be negative? None. Very good. So, the fancy way of writing that is simply saying there are no intervals over which the function is negative. Okay, I'm actually going to skip this one because you're going to graph it just like, and you guys can do this one on your own. I have to skip it because I need to focus on the rest that are a little bit trickier. This is exactly like the other one. Make your function table, put in some inputs, graph it, and then describe it, okay? All right, so this is gonna look pretty simple, but let's make sure we really analyze. It's got a lot of fill-ins. Oscar participates in a charity walk. The graph shows his distance in miles from the water stop as a function of time. Meaning this is how long it takes him to get to the water stop. This is how long it takes him to finish the race from the water stop. How many miles did Oscar walk? Okay, well, this is time. So this is our distance. It said Oscar walked a total of blank miles. From here to here, how many miles did he walk? Read the graph.
3. What?
6.
No. What?
No, just from here to here.
30.
Just from here to here.
6.
Because if you count.
Why are you saying 3? Okay. How many miles from here to here? I'm not asking what the answer to this is, Ricky. How many miles did he walk from here to here? It took him 30 minutes. How many miles was it?
6.
What?
30.
Well, because if you count.
Okay. So
2.
here is his walk.
1.5.
1.5, thank you. Now, the reason it's going down like that is it's going 1.5 miles over the 30 minutes. So the slope is going down because it's taking him that long. But just the distance that he walks from here to here is 1.5. Then he goes back another 1.5. So that's a total of 3 miles. Then it says, Oscar walked blank miles towards the water stop. And how many? So we have 3 total. That means he walked how many towards the water stop? 1.5. During the first how many minutes?
30 minutes.
30, good. See how we're interpreting? And then he walked 1.5 away from the water stop for the last
30 minutes.
30 minutes.
And then the sum of this.
The sum of these distances is the total number. Very good.
You have 1 minute.
The sum of, do you guys have lunch next?
Yeah.
Okay, you guys can hang out for a minute. Just stay out of courtesy for the rest, okay? I'm giving you the answer, so stay with me a few more minutes. So 1.5 plus 1.5 is the total distance. Does everybody understand that? Okay. The reason I really want you to stay is because the next questions are a little bit tricky. So let's just go over these. Okay. This is a little bit tricky. I actually got this one wrong when I started it because of how they convert the answer in the end. For the graph shown, find the rate of change over the interval from 3 to 6. From 3 to 6. I don't know why they can't just move this over here, make it bigger. Okay. From 3 to 6. Well, let's look at those points. It says the rate of change from 3 to 6. What is rate of change?
Oh, the
Yes, very good. Whoa, you get skills. Oh, sorry, that was such a bad throw. Terrible. If you guys want to go to lunch, you have to let me speak, okay? The slope. So we're looking for the rise over the run. Now, this is 2.5, right? It's halfway between 2 and 3. 2.5 to 5 would be what rise? 2.5 to 5, what would be the rise? From 2.5, what? 2.5, very good. So positive 2.5 because it's going up. And then from the run would be from here, which is 3, to here, which is 6. What's the run?
3.
3, very good. So the rise is positive 2.5 over the run, which is 3. But here's the crazy part. It says type an integer or a simplified fraction. This is where I messed up. I thought that this would be okay to type in. And they marked it wrong because they want you to convert it to integers or whole number numerator and denominators. So to make this whole numbers, I would convert it just by multiplying these times 2 and get 2.5 times 2 is 5 and 3 times 2 is 6. And then it would just be, the rise was in what? Feet. And the run is in seconds. So it would be 5 over 6 feet over seconds. I have one more.
Wait.
Do you have the same numbers as me?
Yeah.
Okay. Do you have 3 to 6? So it'd be 5 over 6, and then you have to choose feet over seconds.
Oh,
Okay, this one's really tricky because the graph is a little bit off, okay? The graph is strangely off. It wants us to go from 7 to 10. Yeah? Just give me a second, okay? I don't know why. Okay. They want us to go from 7 to 10, so let's take a look. From 7 to 10. Now, let's look at our point here. See how weird that is? That is actually supposed to go exactly through that interval. Does it? No. Have I emailed the company? You betcha. And then to 10, does that look like it's cutting halfway through this? No, but isn't it cute that it's actually supposed to? So I'm going to put halfway through like that, okay? Because I was like, how am I supposed to calculate that? So it ends up being a whole number and 5. Okay, so from 7 to 10, we have, what is our rise? Which is going down, right, to this halfway point. So it's going down, what? From 4 to 1.5. What would that be? From 4 to 1.5, what would that be? Yeah, 2.5. So it's going down, or negative 2.5. Then it's going over how many from 7 to 10? 3. So our rise is negative 2.5 over 3. But once again, it doesn't want your little decimal in the numerator. So we're going to multiply it times 2, multiply times 2, and we get negative 5 over 6. And then again, we have feet per second. That is it. That is all the homework. The only one you have to do on your own is, I think it was number 6, 5 or 6.